What's up, good people? This is section 4.3, operations with polynomials. We're going to add them, we're going to subtract them, we're going to multiply them. We're going to spend next section dividing them, and we're going to spend 2 days on dividing them because dividing is a little tricky, but adding, subtracting, multiplication I think we can knock out today. So let's start off. Is each of these a polynomial? If they are, then yes, state the degree and leading coefficient, and if no, say why. This first one, yes, it is a polynomial. The degree is 2, as you can see from the exponent here. The highest exponent is 2, and the leading coefficient is also 2, right there. This next one, yes, it's a polynomial. The degree is 3, that's the highest exponent, and the leading coefficient is the number in front of that term, which is an invisible 1, but it's there. This next one, no, it is not a polynomial. Why? Because it has variables in the denominator. This next one over here, no, again, not a polynomial. This stuff inside the square root you could consider a polynomial, but overall square roots are not polynomials. Over here, yes, this is a polynomial. It's a polynomial in multiple variables. They've got g's and m's. And so finding the degree is actually a little tricky. The highest, when it comes to multiple variables, you actually add the 3 plus the 6 to get 9. That's a total degree of 9. And the leading coefficient therefore would be -4. Here, is this a polynomial? No. Why? Because it has a decimal in the exponent. So a polynomial function is a function that has polynomials, or could have polynomials when simplified. So is this a polynomial function? No. Variables in the denominator. What about here? No. Negative exponents. We want only positive integer exponents. And then here, we've got, yes, this is a polynomial function, and this is not. It's got a square root. This one, yes, it is. You're allowed to have fractions here as linear as the coefficients, but you just can't have fractions in the exponents. And this, if you were going to, it's in a different form. It's not in polynomial form, but if you FOILed everything out and got rid of all the parentheses, then yes, it would be a polynomial function. So, adding or subtracting, as I said, we're going to add, subtract, and multiply. When it comes to adding this polynomial plus this polynomial, you can just drop the parentheses, combine like terms, you get 3g plus 12. Here, subtracting is a little trickier because you have to remember to distribute the subtraction to all 3 terms. So this would, the first polynomial, you drop the parentheses, but when you go to distribute, it becomes -4a squared, -6a, -12, and combining the like terms. The quadratic terms combine, the linear terms combine, and the constant terms combine to get to a squared minus a minus 2. Same thing here. Got to remember to flip those signs. Subtraction becomes addition, addition becomes subtraction. And so you get, when you're distributing the subtraction here, you can drop the first set of parentheses, but remember to distribute the subtraction here. You get 7b squared plus 6b minus 7 minus 4b squared plus 2. And then you can combine the like terms. Combine the quadratic terms to get 3b squared. There's no, the 6b stays the same, and then -7 and plus 2 becomes a -5. So that's adding and subtracting. When it comes to multiplication, you can distribute if there's a monomial out in front. So 3p times np minus 7, we got 2p, so it becomes p squared, 3np squared minus, and then you have to make sure you distribute to both terms, you get -3pz, keeping the subtraction. Keeping the addition here, you can distribute and get 12x cubed plus 4xy here. Again, since this is a -5 out front, you can distribute this -5 to the 2c squared to get -10c squared, and then a negative and a minus becomes a plus. This is 5d squared. And then here, distributing x squared to 2x becomes 2x cubed, and then x squared to 9 becomes 9x squared. So that's distributing. That's what that looks like. Now, if you have anything more than a monomial, you could use, for example, if you have binomials, then you could FOIL. Or if it's applicable, you could use the formula that we have, these formulas. So a minus 5 squared, remember, in the formula you have little a is here and then b is here, 5. And so using this formula becomes, using the subtraction version of this formula becomes a squared minus 2ab plus b squared, or little a squared minus 10a plus 25. Here, no formula involved, you just got to FOIL. the first term is 6y squared, the outside terms are negative 9y, the inside terms are 8y, and the last terms are minus 12, or negative 12. So that becomes 6y squared minus y minus 12. Here, using the formula, a is going to equal r, 2t is going to equal b, so then we get r squared, and then this 2t squared is 4t squared. You have to multiply them up and double it, so you get 4rt. Here, we could use this other formula, the difference of squares formula, and then so a is going to equal g cubed, b is going to equal h, and so when you square these two, g cubed times itself is g to the 6 minus h squared. And then, because the formula has subtraction. N squared minus 7, remember, a can be n squared, b can be 7, and so using the formula, you know we have to square n squared to get n to the 4th, and 7 times itself is 49. Multiply them up, you get 7n squared, double it, you get 14n squared, and remember the subtraction, because we have subtraction here. Now, so that's if you have a monomial times something, or two binomials times each other. But any larger than that, and we have to get really super organized, because there's going to be a lot of terms flying everywhere, and we got to make sure we don't none of them slip through the cracks. I'm going to introduce something called the box method, and what it looks like. So if you have 1, 2, 3, 4 terms, this is a quadrinomial times a binomial. You can't. I mean, foiling, you need to have like an expanded view of what foiling looks like. There are people out there who enjoy drawing tons of arrows. Each one of these 4 terms has to be multiplied by each one of these 2 terms. And you could do that if you wanted to, but I prefer to get organized in this particular way, and I find that it helps me a lot. You take all 4 of these terms, and you take the other 2 terms, and if it's a quadrinomial times a binomial, then you need a 4x2 box. And this is just a really great way to get organized and make sure that each one of these 4 terms gets multiplied by each one of these 2 terms. So you line them all up over here and line them up over here. 3x times 4x to the 5th is 12x to the 6th. 3x times x cubed is 3x to the 4th. 3x times negative 7x squared is negative 21x cubed. 3x times 2 is 6x. And then negative 1 times all of these gives you negative 4x to the 5th, negative x cubed, positive x squared, and negative 2. And one more reason why I really like the box method is because if you get organized, and if these are in descending order, like 5, 3, 2, 1, and then a degree of 1, a degree of 0, then oftentimes the like terms that you have to add up are kind of diagonal from each other, or at least in close proximity. So you can see this is the only term that has a power to the 6th, and we write it out, have power of 5, power of 4, but there are two terms that have a degree of 3. And so when you add them up, you get negative 22x cubed, and then all the rest get listed out here. Let's do it again. We got a binomial and a trinomial, so we need a 2x3. The order doesn't matter. Like it could be a 3x2 box or a 2x3 box. It doesn't really matter because multiplication swings like that. So we got z squared minus z plus 5 and z plus 1 over here. And now you can see z squared times z gives you z cubed. And negative z times z gives you negative z squared. 5 times z gives you 5z. Z squared times 1 gives you z squared. Negative z times 1 gives you negative z. 5 times 1 gives you 5. And because they're all in descending order like that, the degree of 2, degree of 1, degree of 0, degree of 1, degree of 0, the like terms that you have to combine are actually super close to each other. They're right next to each other, and they're diagonal. And so we can see z cubed is all by itself here. There's no other like terms to add, but these two actually cancel out. Z squared minus z squared is nothing, it's 0. 5z plus negative z gives you 4z, and 5 is all by itself. So the answer is here. Now, like I said, if you wanted to, you could draw an arrow from this z to these 3 terms, and an arrow from this 1 to these 3 terms, and organize yourself that way. And there are people who do it and prefer that method. I like the box method because, like I said, the terms all are right there. Next, we got 2 different trinomials. So that's going to be a 3 by 3 box. There's going to be 9 terms we have to negotiate. Get organized, y'all. We've got x cubed times 2x squared is 2x to the fifth, because 3 plus 2 is 5. This is going to be 3 plus 1 is 4, so negative x to the fourth, and 2x cubed here. 2 times negative 3 is negative 6, and 2 plus 2 is 4, so it's negative 6x to the fourth. It's super tricky to cycle back and forth between multiplication and addition when you're doing these kinds of things, but that's why you're in honors and you can handle it. Negative x times negative 3x squared is positive 3x squared. 2 times negative 3x squared is negative 6x squared. 2x squared times 1 is 2x squared, and negative x times 1 is negative x. 2 times 1 is 2. So you can see here we've got only one quintic term, 2 different quartic terms, 2 different cubic terms, and 2 different quadratic terms. And they're kind of, it goes 3 to the degree of 3, degree of 2. There's no linear term, but there is a constant term. And the degree of 2, degree of 1, degree of 0. So just if they're descending order, then you can see they kind of fall on diagonals. We're going to add up the red terms. Those are quartics, so you get negative 7x to the fourth. You're going to add up the blue terms to get the blue cubic terms to get 5x to the third, and add up the quadratic terms to get negative 4x squared minus x plus 2. It's a lot to keep track of. Get organized, y'all. The box method is even flexible enough to handle multiple variables. So here we've got the result, we see a y right here, and it's going to make things a little tricky. That's okay. Box method can handle it. We've got a 3 by 3 here, and when you multiply x squared times x, you get x cubed. X squared times y, you get x squared y. 3 times x squared is 3x squared. 3x times x is, again, 3x squared. 3x times y is 3xy. 3x times 3 is 9x. Negative 1 times x is negative x. Negative 1 times y is negative y. Negative 1 times 3 is negative 3. So you can see here we've got, it's kind of harder to spot the terms that are like terms, but the red ones happen to be quadratic, and the blue ones happen to be linear. So I'm going to add those up. 3 plus 3 is 6. 9 minus 1 is 8. So putting all of these terms here, we got the cubic. This is also cubic, but because there are 2 x's and a y. But they're still not like terms, so you can't combine them. And then quadratic, other quadratic, linear, other linear. And I want you to figure out, this is minus something, try and figure out what number goes here. Again, many variables, a plus b times a squared minus ab minus b squared. So many a's and b's flying around. Get organized with a box, with a 2 by 3 box in this case. Again, you could also do a 3 by 2 box if you wanted, but I think it's easier this way. So a times a squared is a cubed. A times negative ab is negative a squared b. A times negative b squared is going to be negative a b squared. And then here, you've got a squared times b. And this is negative ab squared and negative b cubed. Notice that I am, in order to help combining like terms, I'm keeping them in alphabetical order. That was true over here. I always wrote, never mind which one came first or second, I always wrote the answer in alphabetical order. Mathematically, it doesn't matter, but from studentship point of view, staying organized means keeping them in alphabetical order, so you're much more likely to spot like terms. Like if you wrote b a squared, you might not realize that these two terms actually combine, but they do. And so you can see a squared b plus negative a squared b is nothing. They cancel out. And had to fix that. These blue terms combine into minus 2ab squared here, and then I originally thought they canceled, but they don't. They add up to 2 of them, and then this is minus b cubed, so that's the answer right there. Repeated multiplication. So a box method is going to help. If you were going to multiply you're basically multiplying three different binomials times each other in this problem. And you have to remember, like you might say, Bergman, how do I multiply three all at the same time? And really, multiplication doesn't work that way. If you just remember how you multiply numbers, 2 times 3 times 4 is going to be, you really can't multiply all three of them at the same time. You can only multiply any two things together at once. So first you do this multiplication, and then you do this multiplication in order. And actually, the associative property of multiplication states that it doesn't really matter what order you do them in. You could do 3 times 4 first, and then multiply the 2 next. You'll get the same answer. So it doesn't matter which 2 you choose. If you have 3 things to multiply, you just got to do multiplication twice. The first time, I think I'll FOIL these first 2 binomials to get this first, outside, inside, last. And then where the box method really helps is that we can multiply this first term times the first trinomial times the second binomial. And when we do that, we line them all like this. 2x squared times 2x is 4x cubed. xy times 2x is 2x squared y. 2x times negative y squared is negative 2xy squared. Then we have 2x squared times y is 2x squared y. xy times y is xy squared. Negative y squared times y gives you negative y cubed. And because I've written them kind of in alphabetical order, and it's a little bit easier to see where the common like terms are. I made these red here and these blue. You can see you have 2 of them here and 2 of them here, so a total of 4. You've got one of these here, and minus 2 of these here, or negative 2 of these here, so it becomes negative 1 of them here. And then the green terms have no like terms, and so they don't combine with anything, and that's your answer. Urban development. Last thing, and then we're done. The diagram represents an aerial view of a design for a new memorial in a town center. What is known is that a sidewalk that is 12 feet wide with an area of 1,206 square feet will surround the statue with a circular base, but we don't know how big that circular base would be. So we need to calculate some measurements that will help describe the size of a memorial and a sidewalk. I think what we might need to find is the radius and the diameter, maybe even the area. That's what people need when they're looking to build circles. They want to know these kinds of things. The radius would be super helpful because they would know the distance between the very center to the outside. The diameter would probably be good because that's how people usually talk about diameters when they're building stuff. And the overall area would be good because they would need to know how much cement to put down here to make that inner circle. What we know is we know a formula. We know that the sidewalk is going to be 12 feet, and the sidewalk is going to have an area of 1,206 feet squared. What we don't know is r, the radius. So boom, we've got the formula. And then a is 1,206, and then the radius, if you look, this is going to be of the overall large square is going to be the overall large square is going to be 1,206, and then so that's going to be pi times r plus 12. R plus 12 is going to be the overall radius from the center all the way to the outside. And when I said 1,206 square feet, that's going to represent the entire thing, not the donut, but the overall large circle as the area. So now what we have to do is solve for r. So we undo the stuff on the outside of the parentheses first, undo the multiplication first, and then undo the square. You can take the square root of both sides to get that. And then subtract 12. So the radius is going to be the square root of 1,206 divided by pi minus 12. And you can type all that into a calculator and get approximately 7.59 feet, or that would be about 7 feet, 7 inches. And remember, people who are building stuff, they don't want 7.59 feet. They want feet and inches if you're building in construction. If you double that, you get a diameter of 15 feet, 2 inches. And if you plug that into the area formula, you get 181 feet squared. That's all, y'all. Thank you very much for paying attention. It's a great job taking notes. Fun fact, my favorite superhero growing up was Batman, and that's probably because I saw the Jack Nicholson, Michael Keaton Batman movie in my childhood and watched that 100 times. Lots of fun. Take care, and I'll see you in class.